Okay, we're going to take a look here at question 7 on this homework assignment. And this question involves a few steps to it. It's kind of complicated. And it begins by taking two identical spheres where you know the distance they're separated and you know the force between them, but you don't know the charges. And the whole problem is to figure out what the two charges are. What you also know is that they're connected together, which redistributes the charge, so half goes to one, half goes to the other. And then the force is redetermined to be a little bit higher than it was before. So it was 0.075 newtons, and now it's 0.1 newtons. Now, the only unknowns of the problem are the two initial charges. So I've calculated what they are here, and let me show you the steps to get to those answers. So the first step here is to write down Coulomb's law in the first case. So K, Q1, Q2 over radius squared is the force 0.075 newtons. So that's the radius. This is the force between them, and we don't know Q1 and Q2, so those are unknown, which means you can solve for what Q1 times Q2 is. You can't determine them individually, but you can determine what they are when they multiply together, and that's what you get here. So we're multiplying this by the denominator and then dividing by 8.99 times 10 to the 9th. Now, we have that number, and that number is 2.069 times 10 to the negative 12. Then in the second, so all we know at this point is what is Q1 times Q2 gives you this number. Now, the second part, we know that the charges are the same on either sphere, and it gets half of the total original charge. So this is Coulomb's law written for the second scenario. So now the charge on each is Q1 plus Q2 divided by 2. So it's half of the total charge. And then that's squared. So this is squared here. So K, Q squared over R squared. And R is the same as it was before, equals 0.1. That's the new force. So again, just like we did before, now we're solving for what's unknown, but we can't solve for Q1 and Q2. We can just solve for Q1 plus Q2. And so from here to here, we're solving for Q1 plus Q2, and you get the value 0.000, so 3.3 times 10 to the negative 6. Okay. So we know Q1 plus Q2 is this, and Q1 times Q2 is this. So it's a matter of algebra from here to figure out what is Q1 and what is Q2. Now let's say we're solving for Q1. Now, I'm going to call Q1 X here so that it graphs what I'm doing over here. Then X times Q2 would be equal to the 2.069 times 10 to the negative 12. So let me just write it as Q2 right now. X times Q2 equals 2.069 times 10 to the negative 12. That's Q1 times Q2, but I'm writing Q1 as X for right now. Okay, now using this, Q1 plus Q2 is equal to this, I can substitute for Q2 this number minus Q1. And that number is 3.322 times 10 to the negative 6 minus Q1, which again, I'm calling it X here because then Desmos will plot the graph of this and I can figure out the value of X graphically. You could also multiply this through and you get a quadratic and use the quadratic formula to solve for X. But I think it's easier to do it graphically. So that's what I'm doing here, and I've got the answer on the graph here. Now the answer will be where it crosses the x-axis, and you can't really see here unless I zoom in. So let me zoom way in, and you'll eventually see that it is the graph of a parabola. It's hard to tell because It looks so straight here and here, but it's a big parabola. And there's two answers. It crosses through here, and it crosses through here. And those are the solutions for this equation where x solves this equation. And so one of the answers is 8.304 times 10 to the negative 7, and the other answer is 2.4916 times 10 to the negative 6. Those are the two solutions for Q1, and the other is Q2. If you go back to the problem, it says to assume that Q1 is initially less than Q2, which means that this is Q1 because it's smaller, and this is Q2. And so those are your two answers. So recap, you use Coulomb's law in both cases. So this is the first scenario where you just have the two charges and this is their force. And then you touch the two charges together, and so they each get half of the total charge. And again, you wrote Coulomb's law again, but the force is different. From the first one, we get Q1 times Q2 is some number. From the second one, we get Q1 plus Q2 is some number. And then we can combine the two together to solve for one of the unknowns. Now, I just picked let's solve for Q1, but it doesn't really matter because there's sort of symmetry to the equations. It's Q1 times Q2, Q1 plus Q2. So whether you solved for Q1 or Q2, you'd end up with basically the same equation. And I called it X here so that Desmos would plot the equation. And then where it crosses the x-axis is the solution. And so we have two solutions. So if you zoom in, you can see them. Click on the two points where it crosses, and it will tell you the two answers. Alternatively, you can distribute this through, write it as a quadratic, and use a quadratic equation to solve for x. But I think this is quicker and a little bit more visual, so I like it better. And those are the two answers that go into here to give you the correct answer for the question.